You'll notice the title of today's lesson is Verifying Trig Identities. Now, we worked with trig identities the last time we met. Remember, a trig identity just means it's an equation where any angle you put in for the variable will make the equation true. Now, verifying trig identities, in my mind, is easier than what we did the last time because you know where to stop. So let's have a look here. As we stated last time, an identity is simply an equation that states that two trig expressions are equal to each other for all values of theta. Consider for a moment that equation. Show that both sides of that equation equal the same value for pi over 6. So we're going to substitute pi over 6 in there. So we're going to write secant of pi over 6 minus cosine of pi over 6 equals sine of pi over 6 times tangent of pi over 6. Now you might want to keep your stuff you must know cold sheet out. What is the secant of pi over 6? Oh, well, the secant of pi over 6 is just the reciprocal of cosine of pi over 6. What's the cosine of pi over 6?
One half? No, wait.
Square root of 3 over 2.
Oh,
Square root of 3 over 2. Right, right. So if the cosine is square root of 3 over 2, what's the secant?
2 over the square root of 3.
There you go. That's right. Right. 2 over square root of 3. Oh, would you stop? Cosine of pi over 6 equals, what's the sine of pi over 6? 1/2. Tangent of pi over 6 is on your thing. 1 over square root of 3. Now, well, I don't know if those are the same. Oh, but I can get a common denominator. And getting a common denominator is not the end of the world. What's your common denominator on the left? 2 times the square root of 3. Good. So I need a 2. I need a square root of 3. What do I have on the left side? 4 over 2 square roots of 3 minus 3 over 2 square roots of 3. So I have 4 over 2 square root of 3 minus 3 over 2 square root of 3. What's that? 1 over 2 square root of 3 is the square root of 9. Okay? It's all right. What's this? How do you multiply fractions? Straight across. 1 over 2 square root of 3. Oh my gosh. They're the same.
They're not all going to be that.
Now, here's the question. Shh. Is that equation, now notice we've got an equation now, because we've got an equal sign. Is that equation an identity? Meaning, are there other, does it matter what angle I put in there? Do I get a true sentence if, regardless of the angle I put in there? That's what we're going to talk about today, is how to prove it. Whether or not that is an identity, meaning whether or not that's true for any angle. All right, going right here. Though the work above shows that both sides of the equation have the same value for pi over 6, one angle, that's not enough to show that these are the same for all angles, okay? You'd sit here from now till kingdom come putting in angles to make sure that they were true all the time. So instead of being stupid and saying, okay, I'll try pi over 4, okay, I'll try pi over 3, okay, I'll try pi over 5, okay, I'll try, you'd be here forever. You'd never get done. So here's what we're going to do. We're going to take that. We are going to simplify one side and see if we can make it look like the other side. Or we might have to simplify both sides until we make them be the same thing. This is not hard, and sometimes we will factor. And sometimes we will factor. Okay, so let's look right here. To do this, our goal is to rewrite both sides, and it may just be one side, it doesn't have to be both, using the basic trig identities and the Kahuna family to show that each expression can be simplified to the same thing. Often this means the left side can be rewritten like the right side, or the right side can be rewritten like the left side, or both sides can be rewritten to eventually get to the same thing. When it says analytically, that means use algebra. Show that the equations below are identities. Now, what you want to do is you want to start on the side that's more complicated. And I will tell you this. Adding and subtracting is always more complicated than multiplying because you have to get a common denominator. Okay? So here's what we're going to do. You have studied world history. You have studied World War II. Yes? Please tell me you have studied World War II. At some point. You know the Berlin Wall. When we are doing verifying trig identities, the Berlin Wall goes up right through that equal sign. You cannot cross the Berlin Wall because you will get shot. Well, then you just jump right over that fence then. There are East German soldiers right up there, and they will not let you cross, okay? So you've got to work on this side or work on this side, but you cannot do, oh, I'll just do the same thing to both sides. We're proving that they're equal. So you're going to work here, you're going to work here. All right. You say, well, snap, I don't even know what to do. If there are no squared trig functions, I cannot use the Kahuna family. I cannot use Garfield on steroids. He doesn't have any hands. Doesn't need, okay then. If I don't know what else to do, I'm going to get a common denominator. And I'm going to, well, excuse me, I'm going to back up. If I don't know what else to do, I'm going to write everything as, sines and cosines, okay? So, here, 1 over cosine theta minus cosine theta. So, the Berlin Wall went up, and we're working on the left side. So what we're going to do here is we're going to get a common denominator. Now remember, when you do a verification, always keep in mind where you're trying to get. You are trying to get the left side to look like the right side. That's what you're trying to do. If any of you are really good at chess, okay, then this will make sense in your head because you know how in chess you have to look, you try to look a few moves ahead, okay? Here you're trying to always think, will this move that I'm trying to do get me where I want to be? So we need a common denominator of cosine theta. So if we do that, what are we left with? Can I write the Kahuna family on the board? You bet. So now, is there a substitution I can make for 1 minus cosine squared theta? Sine squared theta. So I can write this as sine squared theta. Oh, I'm listening. Go ahead.
So wait, might just be not remembering how to subtract fractions all of a sudden.
Okay. Right here, when I multiplied top and bottom by cosine theta, this will be cosine theta times cosine theta over cosine theta.
Oh, okay, so
No, 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 no,
That's right.
no, no, no. Mm-mm. Partly.
So now we should go to the next slide.
I could.
Because like the way it looks like how it.
So I'm going to show you two ways you can do this one. Question. How'd I get from here to here? Yes, I subtracted cosine theta from both, cosine squared theta from both sides.
Oh, it's still over cosine theta. Okay.
Mm-hmm. Okay. Yeah. Now I'm going to show you something. I could rewrite this as sine theta times sine theta over cosine theta. Do you buy that? Yeah. Is that equal to sine squared theta over cosine theta? Yeah. Yes. And then what is sine over cosine? That is tangent. So this, that's it. So this is sine theta times tangent theta. Oh, but that's what I was trying to get anyway. Done.
Cool.
Now, if I had said I'm going to stop, for those of you who are watching the video, if I said I'm going to stop right here and go work on the other side and see if I can make the other side look like that. So if we had stopped right here, gone to the other side, and keep in mind where we're trying to go, then we'd say, well, sine theta times tangent theta is sine theta over cosine theta, right?
Oh, which is sine squared. We can get it.
Yeah. Oh, but that's sine squared theta over cosine theta. Look at there. Same thing. So you can do it either way. Doesn't matter.
When you get your answer, what do you circle? The answer. Like.
I would circle whatever is the same on both sides. Well, I'm not going to let you, if you got something way down here and something way up here, put a great big equals. No, I'd rather you not do that. Oh, then that's fine. That's fine. Yes, once you get both sides equal to the same thing, stop there, circle what's equal, and you're done. And not even do anything to the right side. Yes, you sure could. I seriously doubt it now that we had that stupid drill. We have 15 minutes. We're at 2:05 today. But we're going to do as much as we can. All right. Now, we're going to try to decide which side is the more complicated because that's the one you want to start on. Which side do you want to try to start on? The left. Oh, but I want you to look at something. What is secant theta times cosine theta? 1. Why is it 1? Because secant and cosine are reciprocals of each other. And when you multiply reciprocals, you get 1. So, I got to prove that the left side's equal to 1. Now, and some of you, you may see it. You may like, I know where I need to go. And this is when the angels start singing, okay? So, cosine theta over sine theta times, look at there. Look here. Don't those factor out? And then cosine theta divided by cosine theta. That's 1. Done.
Holy crap. That was so easy. Wait.
The question was, how did I know that equals 1? Secant theta is 1 over cosine theta times cosine theta. No, 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 no. Okay. Same instructions. Same instructions. Which side is more complicated looking? The left. The left, the right side, okay. I do not want to try to make tangent theta look like the left. That, I don't even know what to do. Okay, so let's start with the left side. I could, fine, let's distribute. You have two choices. You could distribute or clean up what's inside the parentheses first. Does it matter? No. So Mia says distribute. Fine. So that's secant theta times cosecant theta minus secant theta times cotangent theta times cosine theta. Have we touched the right side? Have we crossed the Berlin Wall? No. We haven't done anything to the right, and we're not going to. What are we going to do?
We're going to turn them into things.
What things are we going to turn them into? Turn them into sines and cosines. What's this?
1 over cosine
Times
1 over sine.
minus times times, I'm not even going to ask what that sound was, times cosine theta. I can cancel a little bit. I can factor those out. So let's see what we've got left. Here, we've got 1 over cosine theta times sine theta. Right? Minus cosine theta over sine theta. Everybody with me there? Common denominator. Okay, it'll be in the video. What's our common denominator? Cosine theta times sine theta, right? Our common denominator is cosine theta times sine theta. What do I have now? I have 1 minus cosine squared theta over sine theta cosine theta. Where am I trying to go? I need this to ultimately equal what? Tangent theta. So what's 1 minus cosine squared theta? Sine squared theta. So numerator is sine squared theta. What am I left with? Sine theta over cosine theta, which is, woohoo, tangent theta.
Can you do that dance?
Tangent theta, baby, tangent theta, that's what we're looking for. Wait, wrong one. Way up there, right there, okay? Let's see if we can get through. We got 9 minutes. We can solve the world's problems in 9 minutes. They will all equal. I will not give you any that do not. Yeah, I could have you working all day long trying to make them equal. Yeah. No. Don't you wait. Wait just a minute. We're here, right? Upper right corner. Upper right corner. Which side do you want to start with, left or right? Subtraction and addition is always more complicated than multiplication. So let's start with the left. Start with the more complicated side. Start with the more complicated side. All right. Cosecant is okay. multiply top and bottom by sine theta. What's this give me?
Sine.
1 minus
Woohoo! Cosine squared theta. Betcha. 1 minus sine squared theta is cosine squared theta. Huh? Huh?
but I think cosine times cosine over sine, which is your cotangent.
So if we go over to the right side, I love these. I think these are just fun. So I go over here and I say, okay, cosine theta, but that's cosine theta over sine theta, which is cosine squared theta over sine theta. Woo woo! How I got from blue to green? 1 minus sine squared theta. You can throw something at him. Subtract sine squared theta from both sides. Okay? You okay? I like these too. All right. We're going to see if we can get through this one. What do you do if they're both ugly? You find the side that's uglier. I would. Oh, I think the left side's so much uglier. Wait a minute, wait a minute, wait a minute. You look at the right side. Secant squared theta minus tangent squared theta is 1. Is 1. That's 1. Huh? Secant squared theta minus tangent squared theta is 1. Woohoo! So we know where we got to go. All right. Okay. Change everything to sines and cosines. All right. This is sine theta over what? 1 over sine theta. Mm-hmm. I'm going to clean this one. I'm going to change this one first. Cosine theta over dividing by 1 over sine theta is the same as multiplying by sine theta, which is what? Sine squared theta plus dividing by 1 over cosine theta is the same as multiplying by cosine theta. That's 1. Woohoo! That's 1. That's what I wanted. That's 1. Okay. Look at the one on the right. Do it. Look at, you ought to be able to look at that and do it. Well, it's, look at that numerator. What do you see? The numerator is 1. And what's 1 over tangent? Cotangent, have mercy. This is 1 over tangent x, and this is 1 over tangent x. I know. We're going to stop. I am going to give you your homework, but I'm not going to give it all to you. I mean, I'm not going to have you do it all. Okay?